We know electrons are negative, but where does the essential positive charge in an atom come from? Today, we will explore the Canal ray experiment which led to the discovery of the fundamental subatomic proton. We will first examine the experimental setup, then track the rays, and finally understand their historic significance. First, recall the cathode ray tube produces negatively charged particles, called cathode rays or electrons. In 1886, scientist Eugen Goldstein used a similar tube but made a crucial modification to the cathode plate. He installed a flat metal cathode with many small holes or channels called perforations. When high voltage was applied, he observed faint glowing streams traveling in the opposite direction from the cathode rays. These new streams moved from the anode area toward the perforated cathode. Some of these streams passed straight through the holes, forming the visible rays beyond the cathode plate. Because they passed through the channels, these streams became known as Canal rays. Their movement toward the negative cathode suggested these particles must be positively charged. These positive particles were created when fast cathode rays collided with and stripped electrons from the remnant gas atoms inside the tube. Next, we confirm the charge by applying an external electric field to the Canal rays. The electric field showed that the rays deflected toward the negative plate, confirming their positive charge. The mass and charge of these positive particles depended on which residual gas was used inside the tube. If hydrogen gas was used, the resulting Canal ray particles were the smallest and lightest positive particles possible. This discovery proved that the atom must contain positive components in addition to the negative electrons. Building on this idea, the lightest particle from hydrogen gas was later identified as the fundamental subatomic particle, called the proton. To check your understanding, imagine what would happen if we reversed the polarity of the external electric field. The positive Canal rays would then deflect toward the plate that is now negatively charged. The Canal ray experiment showed that positive particles exist in the atom alongside negative electrons. This finding fundamentally changed our model of the atom and opened the door to modern nuclear physics. Generate your own educational videos for free at eduvids.vercel.app.